Hi, first grade friends. I hope you had a great February vacation. It is time for science. You guys ready? We are going to talk about your science activity you had before vacation. We had a mystery question from Doug, and it was, how do you become a great inventor? And you had to create a bobby dropper. I gave you paper. I told you to use any pin you could find, and you had to make your bobby dropper mimic what a parachute does, right? And that's fall slowly. So what you did first is you put the bobby dropper on the paper and then you crumbled it up. And this was called a fast fall because it fell really fast. The mission or the idea was to create a bobby dropper that could fall slowly, right? What if you just let it go straight? Not bad. Landed on my laptop. You could have also used scissors and cut it or make it look like a bird or a plane or something that travels slowly, right? We are going to finish the mystery and see what Doug decided to do.
Inventing can look a lot like you're just messing around with stuff. You try something, it doesn't work, so you try something else. Here at Mystery Science, we tried a lot of things when we were inventing bobby droppers. We thought this one was a failure. When Isabel dropped it with the pin pointing down, it fell even faster than the fall fast. We'll call that version 1, an epic failure. But failure gives us a chance to try again. Pointing the bobby pin down didn't work, so we decided to point it sideways. We'll call this version 2. We looked at version 1 and version 2 at the same time. Version 2 moved from side to side as it fell. And it fell slower. Nice. We wondered what we could do to make it even better. There are a lot of possibilities, and there's no one right answer. We decided to try turning the paper's sideways movement into more of a swoop, like the swoop of a paper airplane. Version 3, our jet plane dropper, didn't fall down straight like version 1. We couldn't tell if it was flying or just fluttering like in version 2. We talked with each other about what other changes we could try to make that might make it fly better. Isabel noticed that a floating feather has lots of thin strips or fringes that could move separately. So she made version 4, which has thin strips like a feather at the back. Wow, the fringed version really moved. But it also really crashed. Not what we had in mind. So far, it's looking like version 2 is probably the best one for Bobby. But we're still experimenting. Once we start inventing, we have a hard time stopping. We like to see what happens, especially when we get a failure. Have fun, stay curious, and always try to learn from your failures.
So something that Doug talked about a lot was the word failure, right? It is okay if your bobby dropper failed 5, 6, 7, 8, 9, 10, 30 times. It gives you the opportunity to go back, think what you can change, and try again. And that's called improving. What this leads me to teach you guys about today is something called the engineering design process. Lots of big words. Let's read that together. Ready? The engineering design process. And what the engineering design process is are these 5 steps that engineers take when they are doing an engineering activity or project. You'll see the first one says ask, and that's when you find out what the problem is, right? The second step is to imagine, is to brainstorm what you want your invention or your solution to look like. The third step is really, really important. It's called planning. And that's when you draw a picture of whatever it is that you want to invent. Sometimes you might even have to make a materials list or label your materials. Fourth, this is the most exciting step in the engineering design process. It's called create, and that's when you actually get to build your invention. This is when you guys made your bobby droppers, and then you test it out. The last step is something that we've talked about a few weeks now. Rosie Revere did this, you guys did this last week, and Doug just talked about it. And that is making improvements or trying to make whatever it is that you're building a little bit better. Improving is so important. This means that you don't give up, that you keep trying until it works. We're going to watch a quick little video about what it looks like.
Check out the bird feeder, Moby. Oh no, this happened yesterday too. Squirrels keep stealing the food. Moby, we need to build something better. Time for some engineering. What is engineering? Engineering is the area of science and technology that explores designing, building, and improving things to solve problems. Engineers invent technology that can change the way we work or learn, and improve the way we live. They work together to create tools that help us gather information about our world. Engineers build vehicles that help us travel and find ways to keep us safer. They build homes and plan cities and improve how we use resources. Engineers collaborate or work together to investigate problems and explore different ways to solve them. A process is a set of steps you take to reach a goal. Engineers follow a process to solve a problem. How do you find and understand a problem? Think about the world around you. Is there anything that could be better or more useful? Is there something you can create to help someone? The problem is that squirrels keep eating all the food, so the birds don't get any. First, gather information about the problem. You can research online or at the library, ask a trusted expert, or make observations. Let's observe the squirrels in our bird feeder. You may want to take notes, draw pictures, take photos, or even record video or audio to gather information. So, the squirrels climb down over the top of the bird feeder to get to the food. Now that we understand the problem, we can make a plan. How do you plan an engineering project? Start by brainstorming ways to solve the problem. Maybe if we lower the bird feeder, squirrels won't be able to climb down. Good idea. We can also cover the top of the bird feeder so squirrels can't reach the food. Sometimes you can use more than one idea to solve a problem. What should we use to cover the bird feeder? We can brainstorm different designs. A design is a plan for how something looks or works. Cool! We can use a plastic bowl to cover the bird feeder. Now it's time to make a plan to test our design. List all the steps of your plan and think about the materials you need to engineer your design. How do you test and improve your design? As you carry out your plan, observe and see if your design solves the problem. Take notes and collect data or information as you observe. Oh no, the squirrel got into the bird feeder again. Don't worry, Moby. Designs don't always work. The plastic bowl was a good idea, but it didn't work. We should use something that's hard for the squirrels to climb over. Wow, that's a great idea. A plastic bottle is slippery and has steep sides so the squirrels won't be able to climb over it. If your plan doesn't work, you can always brainstorm more ideas or improve your designs. You can move around throughout the process until you solve the problem. There's more than one way to solve a problem, so take your time and try out different ideas. What are you doing, Moby? You engineered a squirrel feeder?
What's great about that Annie and Moby video is that you can hear Annie actually explaining all of the different ideas that she's brainstorming in her head. And she talks about different materials and what those materials feel like and how they work. And that's exactly what a really good engineer would do and what you guys will be doing for our next engineering project next week. This week, what I need you to do is I need you to open up your science packet that I sent home a while ago. If you can't find it, that's okay, because you can do this directly inside of your science journal. You can just write everything out. So for science today, I would like you to write and draw exactly what the engineering design process looks like. We want to get really good at understanding the engineering design process before we use it for next week's engineering activity. So remember, the very first step, I'll help you with the writing part. The very first step in the engineering design process is to ask questions. So you're going to write that word ask on the first line, and then you're going to draw a picture of you doing that step. So what does it look like when you ask questions? Number 2 is to imagine. You'll write that word imagine next to step 2, and then draw a picture of yourself using your imagination. Step 3 is to plan. This is a very important step. This is when you draw a picture and you label your picture. So I want you to draw a picture of you making a plan. Step 4 is to create. I told you this is the most exciting step because this is when you get to build and test out your invention. So draw a picture of what that looks like. And then lastly, you always want to go back and improve your invention to make it better or make it work better. So you can draw a picture of what this might look like for you. Okay, please go back and glue this into your science journal when you are all done. I can't wait to see what your drawings look like. Bye, boys and girls.